All right, so here for Calc lesson 52, this is still the area between two curves, but now this is day 2. Most of it is similar with one small but very, very important difference. So you'll notice here I have for you another equation, area between two curves, but notice instead of x's, you're now doing it in terms of y's. So doing it in terms of y's means you have a dy instead of a dx. These have to be y values from y to y. Instead of doing top curve minus bottom curve, you have to do right curve minus left curve. So let me say that again. When you're doing it in terms of y's, you have to set up your c and your d as y's. You have to put dy for your variable of integration. And instead of doing top minus bottom, you're doing right minus left. Just like yesterday, it's possible that the right and the left curves swap. If they do, it's not harder. You just have to separate them. So look, if you would, at number 1. There are 2 curves, which I graph for you. Again, these problems would be much harder if you had to create the graphs, but I'm going to do it for you. So starting with the purple curve, 3 minus y squared. If you were to graph this with x's, it would be an upside down quadratic with a y-intercept of 3. Because it's a y squared, it's a leftward facing quadratic with an x-intercept of 3. So this purple graph is right here. Mine is color-coded, yours is not, but feel free to label it. Then here's your blue curve. Normally, when you have a linear, you start at the y-intercept and do the slope. Because these are in terms of x equals, you're going to start at the x-intercept and do a slope of 1. So again, it is much harder to graph when it's x equals, but I'm not asking you to do that. I'm doing it for you. So you have your purple curve, you'll have your blue curve, and then notice I found for you the points of intersection. There they are, circle them, highlight them. Those give you your x's and your y's. And just to be clear, these are y problems. So you're going to set up your problem from y to y. As far as the shaded region, it has to be bounded on all sides by the curves. So you're looking at this pink region right here. Again, it has to be bounded on all sides. You can never shade something that goes to infinity. Otherwise, how would you ever possibly find that answer? So graph the problem, which I'm going to do for you. Find the points of intersection, which I'm going to do for you. Shade the correct region, that's on you. And then set up the integration. So A for area equals, put the integration symbol, and you have to go from y to y. So the y value of that region is -2 to 1. Again, it's the y value of these points of intersection. Then you have to do the right curve minus the left curve. For the entirety of the problem, the right curve is the purple one, and the blue curve is the left one. I like to label them R for right, L for left. How do I know for sure that's the right curve and the left curve? If you draw horizontal lines, wherever you start is the right, wherever you end is the left. So your right curve is the purple one, which is 3 minus y squared. That's the top. You then have to do minus, always a minus. Sorry, it's the right curve minus now the left curve. The left curve is y plus 1. Make sure you parenthesize. Then you're going to go ahead and distribute this minus. So that's going to give you a -y minus 1. Go ahead and combine all your like terms. So area equals integration -2 to 1. I'm going to put the -y squared first. I'm going to put the -y second. 3 minus 1 is 2. And again, it should be dy. Dy because we're doing it all in terms of y. Yes? Oh, okay, thank you. Yeah. All right, appreciate it. Other questions about the setup? Again, graph it, points of intersection, shade it, right minus left, simplify, and now we're going to integrate. You integrate the same way we've been doing, even though they're y's, it does not matter. So I'm going to integrate this as follows. -y cubed over 3 minus y squared over 2 plus 2y. Remember, you're then going to evaluate this from -2 to 1. Which number do I plug in first? Top 1. So everywhere there's a y, put a 1. That's going to give me -1/3 minus 1/2 plus 2. Again, for anybody who wasn't here yesterday or just for anybody who didn't quite catch on, this should hopefully help you to make sense of things. Okay, from here, if I just calculate that red part, that is 7/6. Then go back, it's always a subtraction. Now I'm going to calculate the -2 part. And I will tell you, this is where a lot of people are making mistakes. So when you plug the -2 in, you first have to cube it. When you cube a negative, you get a negative, so -8. Then you have to make it negative again. So a negative becomes a positive 8/3. Let me say that again. -2, first you cube it, it stays -8. Then you make it negative, which makes it positive. As far as squaring it goes, when you square a negative, you get a +4. So it's -4/2, which is -2. And then 2 times -2 is -4. That should be -10/3. All right. So this should be 9/2 or 4.5. That's the answer. Find the area bounded by the following. That's right. This is our last problem. Yes. So look at that. What a lot of people are doing by mistake on the homework is they are not able to see the colors. So let me just point this out to you. Okay. This y² + 1, that is the quadratic. So on mine, it's red. Again, I have color coding. You don't. So if you need to do something to make sure you know what's what, by all means. This x = 5. This is this vertical line. This y = 3. That's this green line. This y = -3 is the purple line. So you have to make sure you're looking at the problem so you know how many lines there should be. And in this case, there are 4 of them. Then you have to be careful with your shading. Your shading has to be a bounded region. There's not just one bounded region. There's not 2. There are 3. So one of those bounded regions is here. This is bounded by the red curve and the blue curve. This is the second bounded region, also bounded by the red and the blue with a little bit of green. This is the third bounded region, bounded by the red and the blue and a little bit of purple. You must have a bounded region on all sides. Guys, it's our last problem. Could we just let me do it? Thank you. It is, yeah, see? Seriously. All right, make sure you highlight those points of intersection. You're going to need those. When you go to set this up, remember it says set up, but do not solve. So I am going to have to set up not 1, but 2, but 3 different areas. 1 for each color. You're adding each of those areas together, so everybody's a plus. Shh. It doesn't really matter the order, so I'm just going to go from top to bottom. So that's the blue, that's the yellow, and this is the purple. For each of those colored regions, you have to tell me from what y to what y, and then you have to do right minus left. So look at the blue region. That blue region is from 2 to 3. Remember, it's y values. Then the next region is from -2 to 2. Those are y values. The purple region is from -3 to -2. So again, you have to set them up from y to y. Confused by what? Well, but right now we're just setting up from what y to what y. So the blue region exists from y = 2 to y = 3. The yellow region exists from y equals -2 to 2, and the purple from -3 to -2. It has to go from smaller to larger. Okay, so then right minus left. Look at the blue. When you look at the blue, this is the right curve, which is red, minus the blue curve, which is the left. So here's the right and the left for the blue region. So the right curve is y squared plus 1 minus the blue curve, which is 5. Because it's right minus left. That curve is on the top. Okay? Yep. But again, if you draw horizontal lines, wherever you start is the right curve, wherever you end is the left curve. That's how you can know for sure. All right, look at in the middle. In the middle, here are my horizontal lines. When I draw my horizontal lines, this is the right curve, and this is the left curve. So it's swapped. So you have to put the 5 first, minus the red curve. And then finally, you're back to the purple region. For the purple region, if you draw horizontal lines, you're now back to the red curve on the right and the blue curve on the left. So you're going to do the y squared plus 1 first, and then minus 5. Excuse me? Yeah. So the blue area and the purple area are the same. That's okay. Okay, and then from here, given the time and the motivation, I think you could subtract, integrate, simplify, and add up those 3 answers. But again, I think that we've shown we can do that. So the setup is really the most important part. So if you go ahead and flip to the next page in your packet, it's homework 51. You should have done it yesterday. If not, here's your second chance. Flip again. That's homework 52. That's today's lesson. Make sure you are doing right minus left. And look at the second problem. For the second problem, do not disregard this g of y equals 0. That is this line here on the y-axis. So if you need to darken that in for yourself, do it now.